Yeah, you are welcome to Corrosive Online Tutorials, where complex problems are made easy. In today's video, we want to look at the subject physics. And under physics, we want to talk on physical quantities. So the next thing you will ask me is, what is physical quantities? What is physical quantities? Now, physical quantities are scientific parameters that can be measured. I said physical quantities are scientific scientific what? Parameters that can be measured. That can be measured. Okay? Now, these physical quantity are divided into two. So I can say physical quantities are divided into two. Number one, you have the fundamental quantities. You have the fundamental quantities and you have the derived quantities. I hope you understand what we are doing. Please pay attention. Okay, like I said, the physical quantities are scientific parameters that can be measured. Now, these physical quantities are divided into two. You have the fundamental quantities and you have the derived quantities. Now, let's deal with the first one. What is or what are fundamental quantities? Okay, now fundamental quantities, if you must know, fundamental quantities, okay, are quantities that are independent, on other quantities, independent on other quantities, okay. Or I can say fundamental quantity are quantities that cannot, in capital letter, cannot be expressed in terms of other quantities. That cannot be expressed in terms of other quantities. Okay? Now, so take note of that. Fundamental quantities are quantities that are independent on other quantities. Also, they are quantities that cannot be expressed in terms of other quantities. Now, let's give basic examples of fundamental quantity. Now, basic examples of fundamental quantities. Basic examples of fundamental quantity and their units. Number one is length. And the unit. The unit of length is meter. And in physics, we use the symbol. What is the symbol? The symbol is M. That's the symbol. Okay. Also, mass is a fundamental quantity. And the unit is kilogram. And what is the symbol? Is kg. Like that. Also, time is a fundamental quantity. And the unit is seconds. We use seconds to measure time. And the SI unit is just X. Also, temperature is a fundamental quantity. Temperature, okay? And the unit is Kelvin, and the symbol is capital letter K. Okay, also amount of substance is a fundamental quantity. Amount of substance. Okay, the unit is mole. The unit is mole. The symbol is MOL. Okay, that's not all. We also have electric current is a fundamental quantity. Electric current. Electric current is a fundamental quantity, and the unit is ampere. The unit is ampere, and the symbol is A. Okay. Also, luminous intensity. Luminous intensity is an example of a fundamental quantity, and the unit is candela. Candela, and the symbol is CD. All these are examples of fundamental what? Quantity. Now let's go to the second part, which are the derived quantity. What is derived quantity? Or what are derived quantities? Okay, now derived quantity quantities are quantities, okay, are quantities that depends on two or more fundamental quantity. Depend on two or more fundamental what? Quantities. They depend on two or more fundamental quantities. Okay, example of a derived quantity is speed. Speed, the unit. Now let's look at the formula for speed. Speed is distance over time. You measure this one with meter and you measure this one with seconds. So you see this one is a fundamental, this is a fundamental. So they depend on two or more. So this one is just two. Okay, distance over time, that is speed. The formula for speed is distance over time. And the unit is meter per second. Meter per second. Meter per second. Right? You can write it like this, or you write it like this. Meter per second. Okay, that's the way. Also, velocity is an example of a derived quantity. Velocity, which is displacement over time. That is the formula for velocity. The units for time is seconds, the unit for displacement is meter, and the unit, the SI unit will still be meter per second. Meter per second. These are examples of derived quantity. Also area. Area is a derived quantity, and the formula is length times breadth. Length times breadth. Length is a fundamental quantity, breadth is a fundamental quantity, and the unit of area will be meter square. Meter square. Meter square can be written as meter square, or you write this one, meter square. Meter square. That is the unit of area. Then volume. Volume has a formula that length times breadth times height. Okay, and the unit is meter cube. Meter cube. The unit of volume is meter cube. Volume is a derived quantity. Okay, not only that, density also is a derived quantity. Density, and the formula is mass over volume. The mass of a substance over the volume of a substance will give you density. And the mass of the substance is measured in kilogram, and the volume of the substance is measured in meter cube. So the unit of density will be kilogram meter cube. Okay, kilogram per meter cube. Kilogram per meter cube. Okay. Also, not only that, we also have pressure. Pressure is a derived quantity. Pressure is a derived quantity, and the formula is force over the area. Okay, force over area. Force is the unit of force is Newton, while the unit of area is meter square. So the unit of pressure will be Newton per meter square. Newton per meter square. So we have numerous numbers of derived quantity. In my next video, I'll be talking more on some questions under physical quantities. Thank you.